There is something we call expansion in a solid. So please pay attention as I explain them, and again as I calculate some of the calculation involved in this topic. I still tell the parents, uncles to invite their young ones on this page or channel, because they will learn many things from me on the area of mathematics and physics. So thank you as you listen and pay attention. Thermal expansion is a process whereby solid expands when heated and return to its original shape when cooled. It is a process whereby an iron, for example, when you heat it, it will increase in length. And when you remove it from heat and it cools, it will return back to its original length. It may be volume of it. The volume may increase when you heat it, and when you remove the heat, the volume, it will return to its original volume. It may be area. The area may increase when you heat it, and when you remove the heat, when it cools, it will return to its original area. There is application of it in our everyday life, and there is also consequences in our everyday life. One of the consequences is when you pour hot water in our tea glass at home, the glass we used to take water, the glass we used to take wine. When you pour hot water in it, you see it break, you see it crack. The reason is because glass is a poor conductor. So when you pour hot water inside it, the glass around the hot water inside it will expand, will try to expand, but the glass outside the tumbler will not expand with the inside own. So as a result of the inside trying to expand while the outside is not following, it will cause stress to the glass, thereby breaking it or cracking it. Then our home tumbler is broken. So because of this reason, we don't use this type of material we use to produce the tumbler we use at home. We don't use it in producing the laboratory glasswares. There's a special glass called Pyrex. This glass has low thermal expansion. Thermal expansion is a process, is a tendency of a material to change its shape or length in response to the heat applied to it. So this Pyrex has low of it. Doesn't like to expand like that when heated in response to temperature. So we use Pyrex glass to produce laboratory glasswares. That is why you heat laboratory glassware such as beaker, test tube, conical flask, volumetric flask. They will not break because they use special glass to produce it called Pyrex. So another place we apply this expansion is the iron we use at home, the iron the laundry use in pressing clothes. Iron. This iron now, there's what we call bimetallic strip. This bimetallic strip is a process whereby two metals are combined together. And these two metals that are combined together has different expansion ability. They have what? Different ability in expansion. Look at how it is combined. This thing is called bimetallic strip. When you hit this bimetallic strip that have different ability in expansion, one of it expands more than the second one. If, for example, this is brass and this is iron, brass expands more than iron. So the metal now, when you hit this metal, it will expand. The brass will try to expand, but the iron is not expanding in the same rate with it. Then it will cause the metal to bend. The metal will bend like this because this brass expands more while the iron is not expanding in the same rate. It will force it to bend. As a result of this now, we apply this bimetallic strip in production of thermostat in our iron, the iron the laundry use. Then the iron laundry use, this is the iron. When it is not plugged in power source, it is normal like this. It is now making contact with the another element here that will make a complete circuit when connected to the power. Then when you now switch on your iron to start pressing clothes, the iron will start heating. It will start heating until your iron will be very hot to the extent of burning your clothes if you are not careful. Then the thermostat now will regulate it. How does it work? The heating will now cause this bimetallic strip to bend just like this one, because this down hole expand more than the second one, so it will cause it to bend. As a result of bending, from the heating, it will now curve like this, thereby breaking away contact from the power source. It will break away, causing an open circuit. Then there won't be power supplying again to the iron. Now your iron now will start, the heat of the iron will start reducing now while you still press your cloth. The heat here will be removed, causing the bimetallic strip to go back to its original shape. And while it goes back to its original shape, it will make contact again with the power source, thereby completing the circuit. Then the power will come again. That is why you used to hear noise like kim, 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 kim in your iron. It is a process of regulating the power. It's a process of regulating the heating from your iron. It's very, very vital. Another place we apply this biometric strip is in a fire alarm. We apply it in a fire alarm. So in this fire alarm now, we have it in our schools, industries, hotel, and our homes. So when there is fire outbreak, just like this is bimetallic strip. Then this is the fire alarm. It is an open circuit now. There's no power contact. So when there's fire outbreak in a house, then the heat from the fire will now heat up this bimetallic strip, thereby causing it to bend. Because this one may be copper, this is iron. To cause this metal to bend towards this, as it is bending, to make contact with this, thereby completing the circuit. Then the fire alarm will start sounding. Then people will know that there is fire outbreak. Another area we use this is in bridge we construct. If you go to every bridge now, you see gap, close the gap. This is an allowance made for the expansion, because when a solid is heat, it will expand, and when it cools, it will return back to its original shape. So those gap you are seeing there is gap made to give that allowance for the bridge to expand when heated from sun. And when it is cooled, it will go back to its original shape. Without it, the bridge will collapse quickly. It will not serve a very long time, then it will collapse. Another area we make use of this is in railway lines. If you go to railway lines, you see gap in those iron. This is gap made for the allowance of expansion as a result of heat from sun or any source. So that when sun hit the rail or any heat from any source, then the iron will try to elongate, it will try to increase in length. So as a result of increasing the length, if there is no gap made for it, it will cause the iron to bend, thereby making the rail line to be destroyed in time. So the gap is given so that when tried to increase, it will have gap to increase. So after increasing, when it goes to return back to its original shape, that's another area we apply this expansion in a solid. Then I remember those days we were small. When we came back from school, from primary school, we begin to hear some noise from the roof of our building. This is as a result of expansion in the zinc of the roof. So the zinc tries to expand when heated by the sun. So that time we came back in the afternoon, we begin to hear this noise, king, 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 but we don't know the meaning because we're still in nursery school. Then in the night again, we begin to hear the same sound. Then this second sound now is a result of the zinc returning to its original shape because it's cooling. There is no longer sun. So please, in next video, there are calculations involved in this topic. So in other videos, I will now teach how to calculate some of the questions involved from this. Okay, there are so many of them. There are calculations in expansion in a liquid. There are also calculations in expansion in an area of a solid. There are also calculation in expansion in volume of a solid. There's also calculation in expansion of linear, that is linear expansion of the solid. So when we start to calculate it, you know more. Please, I still beg you to subscribe to my channel, okay? And follow me on Facebook and other social media, okay? The link of my YouTube is on top of this video. Thank you as you subscribe. You will get more from me. Thank you so much, and God bless.